In the last video, I discussed about how do we change the time series data into the regular data frame, and then how to change the regular data into time series data. Okay, so next I want to do the probability and statistics, very basic stuff from probability and statistics. Okay, so I think we did this already, but let me do it again. So how do we generate random numbers from different distribution? Okay, so random numbers from normal distribution, from t distribution, from chi-square distribution, and so on. So this is what you do. So R norm means random number from normal distribution. So it says 5 random number. If you enter that number here, a number here, that is that many random numbers you want to generate from a normal distribution. But it picks a default value of mean 0 and standard deviation 1. Okay, so if you do this, and then again if you write a variable x equals to, it doesn't show any output there, but if you want to see the output, then you need to type that x and then run. Okay, or you can type x here too, it's the same thing. Okay, so that's what you do. All right, so but if you want to generate a random number from a normal distribution with different mean than 0 and different standard deviation than 1, then you can basically do x equals to r norm, that is it generates normal random number from normal distribution with mean 10 and standard there are 10 numbers, and with mean 2 and standard deviation 1, that will give you these are the 10 random numbers from a normal distribution with mean is 2 and standard deviation 1. Okay, so what I'm doing is I'm removing y first. If there is anything saved in this workspace, then we will remove that first by doing rm equals to y. I mean, you don't have to do that, okay, because once you assign a new value, the r will pick the new value, so you don't have to do that, but you can always do that if you want to. Okay, all right. So let us define y equals to random number from t distribution. Okay, random number from t distribution with there are 10 random numbers with t distribution with degrees of freedom is 5. Okay, with degrees of freedom is 5. That's what it is doing. So when I do that, these are the random number from t distribution. Okay, and then so mean is 0, standard deviation is 1 thing, and then the degrees of freedom is 5. All right, so let me do the generate a random number from chi-square distribution. Okay, chi-square distribution, that is n, that is the degrees of freedom. All right, so n is 10, degrees of freedom is 7. So you want to generate 10 random number with 7 degrees of freedom, and the data are from the chi-square distribution. How does the graph of the normal and chi-square distribution look like? The normal distribution, the graph look like this, right? So the graph is just a bell shaped, right? So mean is here. If it is a standard normal, then the mean is 0 and standard deviation is 1, right? So if you pick 10 numbers, then you are picking somewhere close by, because many times it will pick around that, because there are many data around mean 0, right? That's why. So also the t distribution look like the normal distribution, but it may be more flat for the lower degrees of freedom, and for higher degrees of freedom, then it may be more picked, right? And if you want to find numbers from chi-square distribution, it is a right tail test, right? So 0 is somewhere here, right? Because all the values of the chi-square values are greater than 0, and then it may be picking somewhere from here, because there are more data around that values, right? So so the R can generate any data from these distributions, any number of data from the distributions. Okay, so the next thing I want to do is I want to show you how to find area under a normal curve, area under t curve, chi-square curve, and so on. Okay, guys. So let us do, because we did that in the chapter 6 of the elementary statistics. Do you remember that, finding like normal CDF, normal PDF, TCDF, TPDF in your calculator, TI calculator? That's what we are going to do in R directly. Okay, So if you want to find area under a standard normal curve, we use P norm. Area under a normal curve, we use P norm. Okay. And if you want to find out, so always the P norm finds the area left of that value. Okay. So for example, if you want to know, for example, let's say this is a normal distribution, right? So let's say standard normal distribution. Let's take an example of standard normal distribution. Then if you want to find out the area left of, let's say 1.23, that is the area left of that, all the area. If you want to do that, what is the our syntax is P norm, okay, and then enter that number 1.23 and then 0,1. 0,1 is for the standard normal curve. That means mean is 0, standard deviation is 1. And if you do that, it will give you the area left of that. Okay, guys. But if you want to find out the area right of that, suppose you want to find the area right of that. If you want to find this area, okay, if you want to find this area, for example, how do I do that? Is you do 1 minus P norm 1.2301. That means it will find out the left area. P norm find out the left area, and then you subtract the whole left area from 100%. That is 1. It will give you the area right of that. Okay, guys. So let us do this thing in the calculator. What I'm doing here is I'm doing 1.23 there, 1.23. Okay, and let me run that. So x1 is 0.8906. that is, this value is basically 0.89 and then 0.6 or 7, right, if you round it up. How about the other one? So if you do 1 minus, that means, see, for the area right of that, right of, let's say 1.23, right, 1.23, and then if you want to find out the right of 1.23, then you just put 1 minus, right, 1.23, 1 minus P norm 1.23 is the value of x2. So that's what I'm doing. So 0.0193, so 0.0193. That's how you find out the area left of the normal curve or standard normal curve, and then right of a standard normal curve. If the normal curve has different mean, okay, how do you find out the area between x equals to 0.56 and x equals to 1.3 under the normal distribution? Okay, so if you want to do that, suppose you want to find out, let's do that example. So how do we find out the area between x equals to negative 0.56? So x equals to negative, so 0 is somewhere here, right? X equals to negative 0.56 maybe somewhere here, and x equals to 1.3 maybe somewhere here, right? How do you find out the area between those two? What do you think? So you can do P, so let me write 0.56 negative and 1.3. So P norm 1, let me do P norm 1.3. okay, so P norm 1.3 0,1, it is all the area left of 1.3, and then minus P norm, and then you can do negative 0.5601. If you do that, it is finding the total area left of 1.3, but this is the area, right? And minus, if you subtract this area, that is what it is, right? Area left of negative 0.56 is that. If you subtract that, you will get the middle area, right? This is what you do. All right. So let us do that here. So what you do is P norm 1.3, 0,1, and then minus P norm, right? And minus 0.56, 0,1. If you do that, then you get the value is 0.6155. So this is what you get. This is equals to 0.6155. Okay, guys. So this is how you find out the area left of, area right of a number, a g value, or area between two g values. This is what you do. All right. So let me clear the console here, and then it also says that. Let me see this one. So how do we do under the t distribution? Okay, for the t distribution, if you want to find out, by the way, I need to do this next. So area under normal curve with given mean and standard deviation. If the mean and standard deviation are different from 0 and 1, okay, if the mean and standard deviation are different from 0 and 1, then how do we find out the area under a normal curve? That's the next thing we want to do. All right, so if you have a distribution, normal distribution with mean is different from 0 and standard deviation different from 1, let us say that this example has area under the normal curve. So with mean is 9 and standard deviation is 2, but you want to find out area left of 10.3. Suppose this is 9, the mean is 9 and 10.3 may be somewhere here, right? Suppose you want to find out the area left of this, meaning you want to find out this area. So how do you find out area under the normal curve with mean is 9 and standard deviation 2? That is, you do p norm, you want to find the area left of 10.3, right? And the mean is 9, standard deviation is 2. If you do that, it will give you the area left of that, right? Let me find out how much would that be. So go there and then hit enter and hit enter again, because I denoted that by y1. So that is 74.21%. That is 0.7421, right? So you got 0.7421. Okay. So similarly, if you want to find out the area right of that, let's say you want to find out the area right of that. So how do you do? Again, 1 minus p norm, 10.3, because that number is 10.3. Okay, and then 9, 2. So this will give you, let us say what? Oh, this is taking a different number. I mean, you can take the same number, okay, or different number, whatever you need to do there, okay. So if you find out that 10.3 there, then you get 0.2578. That will be 0.2578. That's what you get. That is the area right of that, okay. So how about the area between two values, right? So let's say this is like 9 and then this is say like 11, okay. Suppose you want to find out the area between, let's say, oh, this must go up, okay. All right, let's do this, must go here, okay. And for the between 9, let's say between 9.56 and 11.3, okay. So 11.3 and then 9.56. Let's find out the area between these two with mean is under normal distribution with mean is, let's say, 9 and standard deviation is 2. Let's say that, okay. So we want to do exactly the same thing, same mean and standard deviation, but you want to find out the area between these two numbers, okay. So how do you do that? Is basically you change that mean and standard deviation, 9 and then 2. So this is giving you the area left of 11.3, all the area left of 11.3, and this will give you all the area left of 9.56, right? So if you subtract that, what is happening there is this, right? Because you have a normal distribution, mean is 9, right? So when you do the p norm 11.3, it will find out all the area left, okay. And when you do the p norm 9.56 maybe somewhere here, right? You are finding all the area left of that. So if you subtract the orange area from that black area, so what you get is the area between 9.56 and 11.3. So this is what you do, and then the standard deviation is 2 here, okay. Standard deviation is 2. So this is what you get, 26.47%, okay. So this area will be 26.47%. So this is how you can find out area between two x values under the normal curve, okay. So what you want to do next is let's see, we did that, right? Okay, now we want to do for the similar thing for the t distribution. Okay, for the t distribution on line 85, you see that. So for the t distribution, if you want to find t distribution is also normal distribution, but it may be more flat or depending on the sample size. Okay, all right. So for the t distribution, again, it finds out the area left of the t values. Okay, so if you want to find out the area left of this t value, then you do pt, like a p norm, you do pt. Okay, pt negative 0.54 comma 5 is find the area under t distribution with degrees of freedom 5 and left of t equals to negative 0.54. Similarly, if you do 1 minus that, it will give you the right area, right? Let us do that. So that is the area left of negative 0.54 under the t distribution with degrees of freedom 5. And similarly, this is the right of that. Okay. Now the question is, how do you find out the area between negative 0.56 and do that? So it is the easy thing, right? You just do pt, and then so that is 1.3, right? 1.3. And then comma, what is the degrees of freedom? Is 11, because n is 12, right? The sample size is 12, so the degrees of freedom is 11. Minus you do pt and then negative 0.56, right? Comma 11 degrees of freedom again. So if you do that, then that will give you the area between these two values, which is 59.67%. Okay, that will give you 59.67%. That is for the t distribution. Okay, so we are finding the area under normal distribution, under t distribution. The next is we want to do the area under the chi-square distribution. Okay, so this also find out the area left of this number, left of a number. Okay, under the with degrees of freedom this under chi-square distribution. Again, to find out the area under a chi-square distribution, you do p chi-square, right? P chi-square. And then this is the number that you want to find out the area left of that, and this is the degrees of freedom. If you do that, it will give you the area under the chi-square distribution. This is the chi-square distribution, right? And then 18.5 something, right? So 18.55. So 18.55 maybe somewhere here. 18.55. Okay, you are trying to find out the area left of this. So you are trying to find out the area left of this. So the degrees of freedom is 12, right? That's why the 18.55 is lying on the right side. If the degrees of freedom is big, then these numbers will be somewhere here. Okay, these numbers will move to the left for the bigger degrees of freedom. Okay. So this is actually finding out the area left of 18.55. If you want to find out the area right of 18.55, you need to do 1 minus p chi-square. Okay, that's what you do. Now, and also if you want to find out the area between two values, right, you do the bigger minus chi-square, the bigger number minus chi-square, the smaller number, right? So what you do here is, I want to do between 11.3 and 0.56. and n is 12 degrees of freedom. Let us find out that. We do p chi-square 11.3, and degrees of freedom is 11 again because the n is 12, minus p chi-square, and then what do you get? 0.56, right? 0.56. Chi-square doesn't have negative values, and then 11 degrees of freedom. So what is the area between those two? Is 0.5815. So let us do it here. 0.58. So let us say that value is 0.56, maybe somewhere here, right? And then 11 point, that thing is somewhere here maybe. And then if you want to find out 11.3, 0.56, and you are finding this value, right? And then that is the calculator syntax that you use to find out the area. Okay, so these are all about finding the area under different distribution curves. Okay, so the next thing I want to do is, how do we find out the critical values? So meaning, if the area is given, then how do you find out the the G value or X value or T value or chi-square value. That's what we are going to do next, okay? So see, find the critical values with a given area. Find a G value such that the area left of G is 2.5%. So if you want to find the G values, okay, suppose you have an area given. What it says is find the G value such that the area left of G value is 2.5%. Okay, the G is the standard normal, right? So 2.5% left area. This is 2.5%. 2.5%. What does that mean? That means 0.025, right? You want to find out that G value. How do you find out that? So previously you were given with G and you were asked to find out the area left of G. Now area left of G is given and you were asked to find out the G value. For this we use Q norm. Previously we used P norm, now we use Q norm. Okay, Q norm and then the area. Area is what? 0.025. That's what you do. Look at this code on line number 106 and 107. Okay, this is what you do, and then G1 is negative 1.96. So that G value is negative 1.96. That's the value of G. Okay. Similarly, if you want to find out the G value such that the area right, if the right area is given, okay, if that right area is given instead of the left area, let's say the right area is given to you, okay, suppose the right area is given to you. If this area is given to you, then suppose since this is 2.5% on the left, so 97.5% is on the right, right? That means 0.975. Okay, so in that case, how do we find out the G value? If this right area is given, how do you find out the G value? Is you do G equals to Q norm, and if the right area is given, find out what is the left area first. Left area is 1 minus the right area, right? 1 minus 0.975. If you do that, it will give you 1.96, again negative 1.96. Okay, whether the left area is 0.025 or right area is 0.975, you get the same number here, right? Because that's the boundary of those two things. All right, guys. Okay, so find the G value that in the middle area is 90%. So how do you find out that? Suppose a question is asking you, suppose you have a normal distribution, okay, and you are asked to find out the two G values with middle area 90%. Okay, how do you do that? So this middle area is 90%. So 0.90. So you need to find out this G1 and then this G2. How do we do that? Is, so what is the area outside this shaded area? This is the shaded area, right? What the area outside is 10%, right? So half of the 10% is 5%. That means 0.05, right? So this left area is 0.05. This one is 0.05, 0.05. So to find out G1, you need to do Q norm G1 equals Q norm 0.05, right? And to find out G2, the middle one is 0.90%, and this is 5%, right? So the total is 95%. Because to find out the G values, you always need the area left of that G value. To find out G2, what is the area left of that? G2 is Q norm. What is the total area? Is 95%, 0.95, and then you just close that. Okay, this will give you the values of the G's, right? So let us do that thing. So that is G3 or here negative 1.64. I assume G1 and G2, but there the question has G3 and G4. So anyway, negative 1.64, and if you do for the right number or the right G value, that is positive 1.64, and it is symmetrical, right? That's why you get positive 1.64. That's how you find out the critical values. Okay, so critical values under the normal curve or under the G curve. Okay, so let us do find a T value similar to the G. You use previously you use PT, now you will use QT. Okay, find the area So find a t value such that the area left of t is 0.01 with degrees of freedom is 23. So let us do that. You get c equals negative 2.5, right? And then similarly, if the right area is given, that's what you do. So qt is 0.99, so that the area right of t is 0.01. If the right area is 0.01, then the left area is 0.99. That's why I enter 0.99, because always for the pt or qt, you always enter the left area. Okay, always near the left area. All right, guys. So similar to that, you can do the middle area. If the middle area is given, then you can do exactly the same thing as in the G curve for the T curve, right? And let us do for the find chi-square value such that the left area is 0.05 and degrees of freedom is 11. Do the same thing. D1 equals to Q. Instead of using P, we use Q chi-square and then 0.05, 11. It gives you the area. It gives you the chi-square value for the left area 0.05. And if the right area is 0.05 given, then you enter the left area. Okay, it's the same thing. All right. So let me show you for the chi-square. What do you do for that? So what you do there is, suppose in the chi-square, if the left area, this should go like this, okay? If the left area is given as 0.05, and if you want to find out chi-square left, okay, what you do is q chi-square, left area 0.05, and degrees of freedom is 23. Is that 23? 11. Degrees of freedom is 11. That's what you do. And then if the right area 0.05 is given, 0.05, if the right area is given, but the left area is not given, okay? If the left area is not given, only the right area is given. How do you find out the chi-square right? Chi-square right is basically, you need to enter the left area. You see that? To find out that, you need to enter the left area. How do you enter the left area? This is the left part, right? So this is the left part. So this right area is 0.05, 5%. So the left area will be 95%, 0.95, right? You do chi-square, 0.95, and then 11 degrees of freedom. And if you hit enter that, then you will get the value of the chi-square for those values. So for the first one, it is 4.57. For the second one, it is 19.668. Okay, guys. So this is how we find out the area under the curves, the normal curve, T curve, chi-square curve. And then if the area is given, then how do we find out the chi-square values, T values, G values, and so on. All right. Thank you, guys.